Hi again, and good morning, afternoon, or evening, or whenever you happen to be reading this. We're going to take up the last part of Chapter 6, which begins on 367 in the 12th edition of Hurley's Concise Introduction to Logic. And this is going to be, in some sense, following up here of what you were doing in previous chapters, was taking these and looking at whether certain arguments were valid or invalid, and having to do all of the work each time, whether through direct, that is, long truth tables, whether 4, 8, 16, 32, 64, or 128, it could be, truth tables, lines in a truth table, to recognizing right away various argument forms and fallacies. And these are common ones, and as the chapter makes clear, they're often used in debate, they are often used in arguments that you see on TV and so on, or in the newspaper, even if you don't recognize them as such. In other words, the claim of the textbook and the claim of certain logicians is that this is how we ought to think, right? That is, there is a proper way of reasoning, and that proper way of reasoning is called logic. And there are certain forms of arguing that are going to be valid, and there are going to be certain forms of arguing that are going to be invalid. And we're going to be looking here in chapter 6.6 at the forms that are valid and the fallacies that you can recognize right away as invalid. Okay? So there are common argument forms, right? For example, if P and Q are true, we know that P is true. And then we can always substitute in A or B. And A could be anything, something really complicated like this and complicated like this. If we know that this is true, then we know that this alone is true. We'll come to this. But we remember the and requires that when these both are true, that this is true, that when the line is true itself, right, underneath it, you know, all true, 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 but especially the and, then both sides are true, and therefore we know that that's true, okay? So a valid argument form, as we know, is one that satisfies the truth table test. That is, we never have a line where the premises are true and the conclusion is false, right? And in truth tables, we simply fill out the truth table, right? Each of the lines, whether again 4, 8, 16, 32, etc., looking for a line where the premises are true and the conclusion is false, or we work backwards through indirect proof, as we did in 6.5, and we look to see if there is a line where it could be true and the premises are false. And if we find that line, we know the argument is invalid. If we don't find that line, then we know the argument is invalid. Okay? So now we're going to look at valid argument forms that we see. And so if we're given this, what's called a disjunctive syllogism, and again, we're going to be reviewing this when we get back here into the slides, that the disjunctive syllogism is the name of a particular kind of argument that can be easily checked by a truth table, that's true, and is always valid. Always. So just as I said last time, and I think in the last 2 sections, that when you get an argument form, perhaps like this one, or a more complicated one, and it turns out to be valid, that no matter what you substitute in for the different letters, that argument is going to be valid. Doesn't mean it's going to be sound, doesn't mean that the premises are actually true, but the form of the argument, the form of the reasoning behind it, is going to be valid. It's a valid way of arguing. And so the disjunctive syllogism simply means this. We know that if P or Q, if at least one of the premises is true, then P or Q is true. We also know that if P is not true, then the Q has to be true. Okay, and we could see this in an easy Venn diagram. Okay, and then we could substitute other things in. Either Harvard or Princeton is in New Jersey, Harvard is not New Jersey, therefore Princeton is in New Jersey, right? We'll see this again, but I just wanted to go over the chapter quickly. And again, we could do this again. Now we know that this one is a valid but unsound one because Amherst is a city in Massachusetts, right? And yet somehow, so it's not that it's, let's see what this says. The validity of a disjunctive syllogism arises from the fact that one of the premises presents two alternatives and the other premise eliminates one of those alternatives, this one, leaving the other as the conclusion. This so-called method of elimination is essential to the validity of a disjunctive syllogism. If one premise should present two alternatives and the other premise should affirm one of those, the argument is invalid, unless the conclusion is tautology. Okay, so here's the example. Either Harvard or Amherst is in Massachusetts. Harvard is in Massachusetts. Therefore, Amherst is not in Massachusetts. That does not have that argument form that's up here. See, notice this is a not H, therefore P. This should be a not H, therefore A. Okay? And that's a valid argument form. The argument is invalid here, but it's not a sound one because Amherst is in there. Okay? The pure hypothetical syllogism is one we have seen all semester. Okay, you've seen it in chapter 1. It was mentioned in chapter 2, and certainly we've seen it in some of the Venn diagrams from chapter 4, 4.1, and the Venn diagram chapter. Okay? If W, if P then Q, if Q then R, go straight across, cut this out. P, therefore R. And we know this is always valid. Even if you use for whatever you put in for P and Q. Even if it's W then C, C then P, again, cut those out, W then P, W then P, your conclusion. So that's the pure hypothetical syllogism. Okay? Now again, we're saying if it's the case, right? Modus ponens, again, the is another argument form that is called it's a premise that is it's any argument form having that that is modus ponens. Sorry, I'm misspeaking there. Is a valid argument. So if T then S, if we know that T is true, we know that S must be true. Why? Because we know from the truth tables that if T is true, S can't be false because that is the false one on the premise table, on the truth table. If true, then false is false. Okay. So modus tollens is a little bit different. If you've learned this elsewhere and done this work, you learn modus ponens. They called this the law of the contrapositive. Okay, or the contrapositive argument. That's what I learned in high school. If P then Q, not Q, therefore not P. So you switch it out. Okay, so it's a little hard to understand, but can be understood by the following reasoning process. Okay, so if you're given this one, I think it's pretty clear. If 12 million children die yearly from starvation, then something is wrong with food nutrition. Well, it is the case that 12 million die yearly from starvation. Therefore, yes, we should conclude that something is wrong with food distribution. If this is true and this is true, then this must be true. That's the point. And in all of these, if the premises are both true, then the conclusion must be true, and we know this. Okay? And in modus tollens, again, this is that form of reasoning I think is easy to see. What's called modus ponens, again, the Latin might be the asserting mode, where we're asserting something, we're asserting T. This may, I think, would if somebody just gave this to you, you use this kind of reasoning all the time, you would have no problem recognizing it even without taking a logic course as a valid argument form. Right? You wouldn't say that, you might say, that sounds true to me. This one is a little bit more complicated, but we have to, by the way, we're going to get to this. We can't confuse this, though, with what is a common formal fallacy. We'll come to that. So if Japan cares about the endangered species, then it has stopped killing whales. Leave this aside for now. Japan, and just think for a moment alongside me. Japan has not still stopped killing whales. So then what would you think? Oh, right, Japan does not care about endangered species, right? Okay? So we could put it in symbolic form here, but if you're reasoning correctly, this is what you would have to conclude. If this is true, and this is true, this has to be true. And you wouldn't need a logic class to tell you that. Okay? There is this form of what's called affirming the consequence. Any argument in this form is an invalid argument, right? If Napoleon was killed in a plane crash, Napoleon is dead. Napoleon is dead, and now you're going to see what is wrong. Therefore, Napoleon was killed in a car crash. No, Napoleon could have died for a number of reasons. Okay? So this form of argument is actually often used, and it's a fallacious form of argument. Okay? We also have what's called denying the antecedent. Okay? So this is affirming the consequent. Remember, the consequent is the second part, so we're affirming the Q. Remember, the antecedent, A before C, comes first, right? Not P, therefore not Q. And again, this is another invalid argument form. If Napoleon was killed in a car crash, Napoleon is dead. Napoleon was not killed in a plane crash, therefore Napoleon is not dead. So if the premises are true, the conclusion must be true. Well, we actually know Napoleon is dead, but it's not because he was killed in a plane crash. So again, validity doesn't have to do with the truth of the matter, but you can see that the form of the argumentation is wrong. Right? Just because somebody was not killed in a car crash does not mean they're not dead. They could have been killed some other way. They could have been killed dying slowly on Elba. They could have been killed, in battle at Waterloo, which didn't happen. Right? Then we have the constructive dilemma is a valid argument form that is made up of two conditional statements, and this is just using sort of the law of replacements. And so you just have to, in some sense, follow it along and sort of memorize it. Or in the case of the exams, since they're going to be open book, for the most part, be able to turn to this and recognize that this is a valid argument form. Right? So if P then Q, and if R then S, and we know that these are both true, because this is the true premise. If this is the true premise, then we know that Q or S is true. Right? That Q, so let's just think this through for a moment. If the premises are true and it leads to a true conclusion, this would be a line that you would have on your big truth table, right? Well, let's work this out. Okay? We know that the and, if this statement is true, the and means that both of these have to be true. And so if we go inside there, okay, if P then Q is true, can only be true if Q is true, right? Because this is going to mean that R is true. In any case, you could see how this has to be true, and then Q or S would be true. One of them has to be true. Okay. Let's look at this. We could read this. We're going to read forms of this later. As they get longer, I want to get rid of them. This is another destructive dilemma. P then Q and R, if R then S. It follows then that we have another valid argument form. Okay, so just read through these. These are more difficult to see, but these are ways of looking at the argument form. And with refuting constructive and destructive dilemmas, we'll be able to deal with that when we get into the slides, right? So we've been looking at invalid forms as well, and I think we're set up well here to go look at. We can see here that we have page 375 a summary of all of the valid argument forms: disjunctive syllogism, pure hypothetical syllogism, modus ponens, modus tollens, constructive dilemma, destructive dilemma. And then we see the two absolutely invalid argument forms, always invalid. If P then Q, Q therefore P is always invalid. If P then Q, not P, therefore not Q, denying the antecedent is always invalid as well. And if you pick up, if you have the whole book, you'll notice that this is inside, I think it's on one of, yes, the rules of implication is on the last, if you go to the hardcover and look at the back hardcover on the inside, you'll see all the rules of implication are there. Okay, we're going to get some others later. For the next chapter, we'll need the rules of replacement. Okay, but this is helping to get us ready for basically chapter 7. Okay, and again, these could be, you could substitute very, very long statements in for P, very long propositions in for Q, but still, if it follows this form, it is incorrect, no matter how long it is, right? And so I think that's good enough for now, and then you'll see that the exercises attempt, you should go through them and then see which ones are valid or invalid based upon these argument forms that you've already been given. Okay. So now let's go in here. We're going to do view full screen. We're still in chapter 6, but we're on the last section. And we're going to do argument forms and fallacies. Okay, so if you see that there's 9 of them, we're going to have a little bit of work to do today, but hopefully we'll make it go quickly. So we introduced 6 valid argument forms that you've seen in the book, and 2 invalid ones. Any argument recognized as having one of these forms can be immediately identified as valid or invalid, respectively. So that's what I've been saying throughout. If you get an argument form that is valid, right, through the use of a truth table or an indirect truth table, then you know, no matter what you stick in for P or Q or R or S or what have you, that if it has that form, it's always going to be valid, or if it has that argument form, again, you see it elsewhere, it's going to be invalid. Okay? It just so happens these are the most common argument forms that are that come up often. Okay? So the disjunctive syllogism is always valid, P or Q, not P, therefore Q. If these premises are true, the conclusion is always true, right? Because if this is true, then one of them has to be true. If not P is true, Q has to be true in order for this to be true. This will be one of the lines on a truth table, but you don't have to do a truth table. You simply have to just memorize that if you see this form, it's a valid argument form. Okay? So the first premise presents 2 alternatives. The second premise eliminates one of them, leaving the other as the conclusion. Okay. The second valid argument form is called pure hypothetical syllogism. I've been saying this since chapter 1. It is abbreviated HS, so do look for that. Disjunctive and hypothetical syllogism. P, therefore Q, Q, therefore R. Cross these out. It's P, therefore R, P, then R, and that's what you have. Okay? It's a valid argument form. Okay? So it is always valid. So for example, we could have if gasoline is ignited, then it burns. If gasoline burns, then energy is released. Therefore, if gasoline is ignited, then energy is released. Okay? And again, you could put it with different lettering, right? But it's the same form, right? Do you see how it's if I then B, get rid of the B's, and it's if I then E. If I then E is the natural conclusion. Okay? This is the proper form of reasoning. Okay? So again, this is the kind of, we could put it in, symbolize it here, but it's the exact format that we have up there. So don't get confused at all by the letters. Just as long as it has that form, right? Just because a circle may be red or yellow or green or whatever, it's still a circle, right? Well, just because these have use different letters, the form is exactly the same. Okay. So the third valid form is called modus ponens. If P then Q, P, therefore Q. If this is true and this is true, this has to be true. Because we know that the one place on the truth table that isn't true is when P is true and Q is false. When we're told P is true, therefore Q has to be true. That is a line on the truth table. It's always valid. Okay? And we could just think of it this way. If Julia Roberts is a movie star, then she is famous. Julia Roberts is, in fact, a movie star. Therefore, Julia Roberts is famous. And again, like a triangle, square, or circle, whatever color, whatever color pen or pencil you use to draw it, it's still a square or a circle. Well, still, it has the same format, even if the letters are changed up because you're using movies, M for movie star, F for famous. Movie star, famous, right? So let's use this section for practice, okay, involving the first three valid argument forms. What is the form of this symbolized argument? Okay. It's a lot here going. They're actually making it a lot easier here because they're giving them to you, right? You have DS, which is this disjunctive syllogism, HS, which is hypothetical syllogism, and, of course, this form too, right? Okay, so which one is it? If K then R, if R then N, if K then N. That has to be the hypothetical syllogism. Okay, it's a pure hypothetical syllogism. Okay, so what is the form of this argument? Right? Is it the disjunctive syllogism? No, it's this one. Right? Okay, it's modus ponens. All right. And now we're going to get to disjunctive syllogism because it's the last one left. It looks exactly like that. S or T, not S, therefore T. If this is true, this is necessarily true. That's what we're looking for. Okay. So now let's introduce the next three valid argument forms. This is called modus tollens, MT, and is always valid. P, therefore Q. Again, this could be the law of the contrapositive if you learned this in algebra. For some reason, it was a subsection of my math in 8th, 9th, or 10th grade. Matter of fact, I forget when. But in any event, we were given these argument forms when I was in high school. It was given a slightly different name. And we used different, at least in New York, we used different symbols, sorry. So instead of a horseshoe, we used actually a straight arrow. But in any event, whatever it is, it's that argument form. Okay. So now, sorry, just pouring myself some water. The first premise says that if we have P, then we have Q. But the second premise says that we don't have Q. Thus the conclusion says that we don't have P. Right? Why? Because if P, then Q, well, if this is true, and not Q is true, therefore we know that not P has to be true. Okay. Okay, why is that? Because if this is true, not Q, and not Q is true, it just follows as a valid argument form. Okay, we just don't have P. Why? Because if so, this would have to have a format of if true, then false. And since not Q gets rid of that, we know that not P has to be true, true as well. Right? In other words, not Q, not false, is true. Right? Therefore, not P is going to be true as well. Okay, so we have true, true, true. That would be a line in a truth table. Okay, so here, just let's use modus tollens again for the law of the contrapositive. Again, like any circle, even if we have different letters, it's still the same format. If Prince Charles was born in Chicago, then he is a Native American. Prince Charles is not a Native American, therefore Prince Charles was not born in Chicago. Right? You could see, just even without looking at any of this, that follows logically. Right? That you use this logic all the time without even knowing. Okay? Right, so this is modus tollens. Now let's look at the difference between modus tollens and modus ponens. Modus ponens and modus tollens. Right? Okay? Modus ponens moves from the left to the right, from P to Q. Modus tollens moves from the right to the left and negates it. Okay. This is called the constructive dilemma. It is always valid. Okay. It is abbreviated as CD. Any argument that has this form, of course, is valid. Constructive dilemma resembles actually two cases of, it's actually a combination of modus ponens and the disjunctive syllogism. All right, so taking this information to the first premise, P gives us Q, and R gives us S. Thus, the conclusion says we either have Q or S. Okay. So, it's always valid, right? So if Susie moves to Miami, then she'll suffocate in the summer. And if she moves to Buffalo, then she'll freeze in the winter. Susie will move to Miami or to Buffalo. Susie will suffocate in the summer or freeze in the winter. See if you follow that down, right? How the constructive dilemma does follow, even as it looks extremely complex. But this is fairly straightforward. If Susie moves to Miami, Miami is notoriously hot in the summer and muggy. But if she moves to Buffalo, she'll freeze in the winter. Buffalo is notoriously cold in the winter. Susie will move to Miami or to Buffalo. She's only going to go to one of these places. Therefore, she'll suffocate in the summer, or she'll freeze in the winter. One of these will be true. So this is a true premise leading to a true conclusion. Okay. I don't think that one part is as complicated as it looks when you just sort of speak it out loud, especially with an example. You said that as complicated as it is, it makes sense. Okay. This actually brings together modus tollens, disjunctive syllogism. I don't know why they say two cases of that, but that's fine. The second premise says that we have either not Q or not S. Take this information to the first premise, not and okay. But let's just look at it this way. If Susie moves to Miami, then she'll suffocate in the summer. Again, we've seen this before. And if she moves to Buffalo, then she'll freeze in the winter. But now we're going to do something different. She'll not suffocate in the summer. For Susie will not move to Miami, or she'll not move to Buffalo. Right? And you can see how that logically follows. Okay? And if we were to do a truth table of this, we would see that it does have validity. Okay? And it's true premises leading to a true conclusion. Okay? So here we're going to get some practice. So what is the argument form here? Right? Is it modus tollens? Is it the constructive dilemma or the destructive dilemma? Right? Which one is it? Okay. Well, let's see. Is it modus tollens? No, we don't have a negation. Right? Is it a constructive dilemma? Well, it does seem to be constructing, right? It's an and. Or destructive dilemma. Let's see if it's constructive dilemma. That's right. It's the constructive dilemma. The argument form that we've already seen. What is the argument form seen here? If S and N, not N, right? We negate the consequent. Therefore, not S. Therefore, so if this premise is true, this premise is true, this premise has to be true. We would find out from a truth table, and that is modus tollens, or the law of the contrapositive. Okay, now we're going to get the destructive dilemma, just by process of elimination. We've only been learning 3 here. If T then K, and, both, if T then K, and, and, if H then E, not K or not E, gives us the conclusion, not T or not H, right? Destructive dilemma. They call it destructive because we're negating. Okay. So now let's look at some invalid argument forms. Okay? first one is going to be affirming the consequent. Affirming this, saying this is true. Because remember, what we're doing here is, if this is true and this is true, we're saying this has to be true. But when we find out that actually, this would be a line that was false. So affirming the consequent is a invalid argument form. Okay? In this form, the consequent of the conditional statement Q that is, you're saying it's true, but it does not lead naturally to P by order of reasoning. Okay? So this is invalid. Look how close it is to this. And you'll see people actually quite often. Okay? I think the Napoleon is dead one is actually quite good, right? If Napoleon is dead, then he died of a heart attack. He's not dead. Well, right? But people do use this invalid form over and against this valid form of reasoning. Okay? So do not confuse those. Again, you could put in other letters for it. If Napoleon was killed, right? If Napoleon was killed, using K here, in a plane crash, then Napoleon, and again, you could use N here. You could use D here. They're using what sort of like is the verb there. D, therefore Q, right? Therefore, Napoleon was killed in a plane crash. Sorry. Killed in a plane crash. Right? But just reason that along. Don't even know, and you don't even need to know anything about history, because we're not testing for soundness, right? If Napoleon was killed in a plane crash, then Napoleon is. If somebody's killed in a plane crash, they're dead. Napoleon died. Absolutely, that he had died in a plane crash? No. Napoleon isn't dead, but he could have been killed in any number of ways. So just because this premise is true and this premise is true does not mean that the conclusion naturally follows. Antecedent. The previous one was close to the Otis, bit like Otis told the scene Q how you'll see that reason through yourself without having to take a logic class. Okay, so this is an invalid argument form, right? In this form, we deny the antecedent. That is, we negate what comes first, the antecedent, right? In an if-then, just to review, what comes first is the antecedent. It has the letter A. And what comes second is called the consequent. If the antecedent, therefore the consequent. If, then the consequent, not therefore. And again, as I always say, A always comes before C. If you have a hard time memorizing whether what's the antecedent, what's the consequent, the antecedent is always before the consequent. We deny, right? We put a negation sign before the antecedent, so it's denying the antecedent, is an invalid argument form. That's where it gets its notice name from. But notice, do not confuse denying the antecedent, which looks a bit like modus tollens or the law of the contrapositive. Right? If P then Q, not Q, therefore not P, is not like this. These are two very different argument forms. One is valid, one is invalid. Okay? So here we have denying the antecedent. We know already it's invalid. But let's reason it through. If Napoleon was killed in a plane crash, then Napoleon is dead. Okay? So we're taking that to be true. Napoleon was not killed in a plane crash. Therefore, Napoleon is not dead. No. I mean, if you reason this through, just because somebody, so if this is true and this is true, the conclusion does not necessarily follow, right? Reason through. If he was not killed in a plane crash, well, doesn't mean he's not dead. He could be very much alive. Forget history and the fact that he is dead. Just because he wasn't killed in a plane crash doesn't mean he's not dead. We can use a contemporary figure, right? If Donald Trump was killed in a car, is killed in a plane crash, then Donald Trump, sorry, just picking out another leadership figure. So if you're a fan of Donald Trump, just leave that one alone. But don't take it as a projection of what I hope. If Donald Trump is killed in a plane crash, then Donald Trump is dead. That is true. If Donald Trump is not killed in a plane crash, therefore Donald Trump is not dead, right? And in fact, Donald Trump is very much alive. So it doesn't automatically lead to that conclusion. It doesn't naturally lead to the conclusion. So therefore, it is invalid. And so notice that we can use very different letters, but as long as they have the same format, if K then D, not K, therefore not D, you're doing okay. So we're going to do 2 practice problems because they're 2 invalid forms. Process of elimination will help you, by the way. So we have, we only have to choose out of the 2. What is the form of this symbolized argument? If G, then J, not G, therefore not J. Well, we're negating something, so we're denying the antecedent, right? Dn. So what is the form of this argument? If D, then I, therefore D, right? This looks like modus ponens, but it is not. It is affirming the consequence. We're saying this is true. True, true. This would have to be true. If it's not, if we did a truth table on this, we would quickly find that this is an invalid argument form, and this is called affirming the consequence, AC. So we get more practice problems involving all 8 of those forms. That is the 6 valid argument forms and the 2 invalid argument forms. If R, then S, R, therefore S. That is going to be modus ponens. Okay. Again, keep your book near you for the homework assignments, so that you can just quickly look over. You'll memorize these through the work that you do, both listening to this lecture, doing the extra problem sets that I provide on the website, and also from doing the homework. Okay, so this is modus ponens. If R, then S. If that is true, if R is true, S is not absolutely true. Okay, it follows deductively modus ponens. Okay, M or T, not M. Therefore, T is true. True, true. This has to be true because if it's not M, if this is false, this has to be true. This is going to be one of the lines in a truth table. Okay? So this is the disjunctive syllogism. If R, then F, R, therefore F. Again, we have modus ponens. Okay? If K, then B, not B, therefore not K. Right? Now we're not affirming the consequent, right? She's denying the consequent, which is another way of saying modus tollens is the Latin form of that. Okay? So again, I know it can be confusing because we're using Latin names and Latin terminology. That is how it's come down to us through logic. And quickly, when people advance in philosophy or in computer science and so on, where logic is often used, people quickly say modus ponens, modus tollens, etc. Okay? So what is the form of this symbolized argument? But part of this, maybe just pausing, part of this is to show you that behind natural language, reason, rationality, according to the text, reasoning should go along this way if we're reasoning properly. And when we're not reasoning properly, then we're being invalid. We're not reasoning properly. Okay, we're not giving true, good faith arguments. So, both if S and D and if n then g is true, s or n is true, therefore d or g is true, right? We have the constructive dilemma. So I always think of the and as constructive. You're putting things together, okay? You don't have anything negative here, like destroying, so there's no negations, which we would get. So it's a constructive dilemma. That's how I tried it. I think way back when, that's how I memorized which was. If C, then J. Not C, therefore not J. Okay? Well, we know that's not modus tollens, because modus tollens would be not J, therefore not C, right? No, we have denying the antecedent. Denying A, what comes first? A comes before C. A comes before the consequent, right? If the antecedent comes before the consequent, not C, therefore not J. So therefore, we're denying the antecedent, okay? Now we have another one, another longer formatted one. If both P, then therefore A, and if S, then F is true, and it's true also that not A or not F is true, then does it follow necessarily that not P or not S is true? Yes, this is the destructive dilemma. Okay, so what is the form of this symbolized argument? Remember, this is the one where if H then L, if L then B, if H then B, right? This is where we cross these two out and just go if H then B. There we go, right? That's the perfect hypothetical syllogism, or pure. Okay, and again, H could be a long set of parentheses and so on. Okay, it could be this very huge sentence, but it just has to have it. So the next observation we must make about recognizing the argument forms is that the order of the premises is irrelevant to the form of the argument. So it might come to be that you have to move these around. Okay, so this is modus ponens even if we just have to move them around. So even if the premises are different, it doesn't matter. It's still in the form of modus ponens. So we just have to mentally switch them. If B, then K. B, therefore K. Doesn't matter the order of the premises. The form is still the same. Okay. So let's do some work where we switch it up a little bit. That is, move the premises around and see if the same thing works. Okay. So if E, then D. D is true. Therefore E is true. Okay. If E, then D. D is true, right? Therefore, E is true. That is, the symbolized argument is affirming what? The consequent, right? We're saying D is true. If E, then D is true. Therefore, E. Okay? Affirming the consequent. Okay? So what is this one? If S, then Q. If T, then S. Therefore, T, then Q. We could quickly switch this around so that we have the S's going there. But we already know that this is the hypothetical syllogism, right? It's not a constructive dilemma, it's not the destructive dilemma. Okay? It's a pure hypothetical syllogism, right? We just cross those out, and we have if T, therefore Q. If T, then Q, sorry. So what is the form of this symbol? Right? We just move this up. If B or C is true, not B is true, does it necessarily follow that C is true? Yes, indeed, that does follow if we did a truth table, and we know that this is the disjunctive syllogism. Right? So what's this argument form? Right? So we just switch these around mentally. If S, then M, not M, right? Therefore not S. And that's modus tollens, or the law of contrapositive. Okay. So negated statements. The next topic concerns negated statements substituted in place of P, Q, and R of the argument form, just like simple statements. Negated statements might be substituted in the place of P, Q, and R and S of the argument forms, again, as it's like simple statements. So for the next, this symbolized argument form has the form of modus ponens. So now what we're showing, though, is even if, and this is going to be a little bit confusing, even if, right, this follows the same format because it's the same, right? It's the same thing. So you almost treat this as like one letter, right? This is modus ponens, okay? Not D, therefore H. Not D is true, therefore H has to be true. Okay? If true, then true. True, therefore true. Right? Modus ponens. So even if there's a tilde in there, it can get a little confusing because we do have argument. We have denying the antecedent and other invalid argument forms that follow from that. But this one is modus ponens. Okay, even if it has a tilde in it. Okay. Right. So many dilemmas, the disjunctive premise is a tautology, P or not P. Right. P or not P is always true. Right. This if we did the quick truth table, this true false true false. Well, it's always true. Right. Because all you need is one side to be true, and then we know P, or there's only two possibilities, right? True or false and true if you negate it. So constructive dilemma. We could see the constructions there, even though we have a not B. Just again treat it like one same letter, therefore N or F. Okay. So we'll do some practice problems using negated statements. Not Z or not B. Now a double not Z, right? What is the symbolized form of that? That actually tells you that this is not true. This also works in grammar. It's not the case that zebras are not brown, which means that zebras are not brown, right? And so you're negating this. You're saying this is not true, and therefore this has to be true. So if true, then true is true. So even if you have two tildes, a negation of a negation gives you a positive. Okay? So that is a disjunctive syllogism, of course. Again, we have something different here. This is going to be denying the consequent, right? And what does the denying the consequent happen? All right, we're negating the negation of the K, which means which means what? Well, we just treat this, put this in parentheses as like one letter. Just treat it like one letter. If P, then Q. Not Q, therefore not P. That was modus ponens. Modus ponens, sorry. All right. What is the symbolized form of this? Well, we have a fallacy here. Not R, therefore not M. Not R, therefore not M. Now, even though there's negation over here, this is all, right? Sorry, this is, I almost said, this is, okay, sorry. If not R, therefore not M. Not R is true, therefore not M has to be true. Does this follow? Yes. Even though we have the negation here, just treat it as one letter. It has the form then of if P then Q, P therefore Q, which we recognize as modus ponens. Okay. Here again, we're going to get what? This is the constructive dilemma, right? Just treat it like one letter, right? And therefore, you get the constructive dilemma, right? The second premise is really just a tautology. This is always true. Okay? So if this is true and this is true, this has to be true. So again, let's do some more with some negated negations. Sorry. So if A, then not L. not L, therefore not P, A, therefore not P. Again, cross out the ones that are the same, treat them as just one letter when you see the negations. A, therefore not P, then not P, I keep saying that, therefore, right? You have this, that's the hypothetical syllogism. We've been seeing this since the first chapter, right? The pure hypothetical syllogism, okay? Not J, if not J, then T. If not J, therefore T. Well, let's just replace these, right? Not P, P, therefore T. Not P, therefore T. So that's denying the antecedent. We're denying it. We're giving it an extra negation. And so that's the format here. Not S, then not T. Not T, therefore not S. Now we're going to have another invalid argument form, because all we're doing is taking this and putting this here. We're affirming the consequent. Affirming it, saying it's true. This is true, therefore this has to be true. No, it does not. It's an invalid argument form known as affirming the consequent. So what's the symbolized form here? Well, we see a lot of negation here, and therefore we're going to have the destructive dilemma. But let's just go. Not Q, if not Q, then not it. Sorry, both if not Q, then Q, and if N, then not Q. Not Q, or not Q. Therefore not Q, K, therefore not N. Now this is a tautology, right? So it's either a constructive dilemma or a destructive dilemma. So let's see what happens if we go constructive dilemma, right? Right, we do have that and, right? But no, the second premise would have to be not K ren. As I said before, it's the destructive dilemma. Again, you just have to look at the form and just treat these sort of, like when you see them, as just their own letters. And that then get negated. Okay? So many symbolized arguments that are not instances of the argument forms presented in this section can be rewritten so that they become instances of those forms. In other words, there are many symbolized arguments that don't have the form that we've seen, but we know that they are the same. Okay? Not P is logically equivalent to P. I wish this was brought up actually earlier in the chapter, but you know this from English grammar, right? If you say that it is not the case that John is not going to the party, that means that John is going to the party, right? If two negatives makes a positive. It's not the same as morality, where two wrongs don't make a right. In logic and in English grammar, two negatives make a positive. Okay? They are equivalent. All right? The reason I say that is because that's in some of the problems for 6.1, 6.2. This rule asserts that double tildes can either be inserted or removed immediately before any statement. That's right. So it's equal to P. Just get rid of it. So not P is logically equivalent to P. So let's see. We have Q, K. If K, then not R. R, therefore not K. This might be a little bit more difficult, but then what's happening here? To get this, you're denying the consequent. That's what I call modus tollens sometimes, just to help out, because we have affirming the consequent, affirming the antecedent, which is invalid, denying the consequent, but the law of the contrapositive, is we're doing not R, which is R, therefore not K, and this is modus tollens technically. Right? So you apply the double negation to the second premise, and then you can see more easily that it's modus tollens. Okay, so you can go either way. You could do R, or you could just put in, replace that with not R, and then you would see that it's negating, if you treat this as one letter, negating that, therefore not the antecedent, right? And you have the argument form of modus tollens. All right? Again, this is rewritten so to show it as modus tollens, right? Which leaves us with not K as the conclusion. True premise leads to this true conclusion. So that's one way we can rewrite things, is just using the negation. Okay. So we're going to do some practice with the double negation. Not E, therefore F. E, therefore F. So if we rewrite this as, so it could be modus ponens. No, if it was modus ponens, this would be exactly the same, right? But if we rewrote this as not E, we would see that as denying the antecedent, right? Not E, denying the antecedent. Again, on the quiz or exam, whatever they're labeled on the actual test that you get, you're going to have multiple choice. So go through the multiple choice. Is it modus ponens? No, modus ponens takes this and says it is true, therefore, what? This is not the same thing though, right? It has to be negated. This is not E, right? And so it is denying the antecedent, right? You apply the double negative and you can see it more clearly. How should we evaluate this argument, right? Well, this is going to be not S. S equals not S, and therefore it is T. So it's a disjunctive syllogism, right? You apply the double negation to it, and then you can see, following from the last section that we did here, that this is a valid argument form. And then it gets a little bit more complicated here, but again, we have either right, this the disjunctive syllogism, modus tollens, and so on. So, what do we have? B, therefore not H, and if C, then not J. Well, what we have here is really not H or J, therefore not B or not C, right? So let's see. Is it the constructive dilemma? Incorrect. For constructive dilemma, the second premise would have to be B or C, and the constructive conclusion would have to be not H. Okay, so let's see. Is it modus tollens? No, we don't have anything like that. No, we don't have an if-then in the second. Sorry, a not. We don't have an or in there. So is it the? It is. Sorry. So once we apply the double negation, we can see more clearly, right? It's a destructive dilemma, by the way. How should you evaluate this argument? Not N, therefore not F. F, therefore not N. Now, this is equal to not F, therefore not N. Well, that is a good argument form. That's modus tollens. Okay. Another rule that's useful in evaluating symbolized arguments is called commutativity. Okay? P or Q is logically equivalent to Q or P. They can be in any order, right? Either John is going to the party or Mary is going to the party, right? Either Mary is going to the party or John is going to the party. It's the same, has the same exact meaning. If P then Q is not logically equivalent to if Q then P. That should be fairly obvious, okay? P or Q, so community reversed only if it's every other operator we have, and this. That is, you can switch P and Q, or it is equal to Q and P. P triple bar Q is equal to Q triple bar P. The only exceptions, the one operator that we're given where we can't just switch them one back to the other. Okay? So, again, we can switch S, therefore not S, therefore M. Well, we can write this as S or M, not S, therefore M. And then we do get the disjunctive syllogism in its normal formatting. Okay? So a way of rewriting the syllogisms, these arguments, in a way that they might be spoken of or just, spoken in everyday language and then symbolized, and you might have them in a different order, but cumulativity is helpful and important because it helps you recognize that you can move things around a little bit and still have it logically equivalent. The only time is when you have the conditional or an implication, as it's called here in this chapter. Okay. So if we apply cumulativity, then you just put not s or therefore, right? So it's this looks like the normal disjunctive syllogism. So just be careful. See the horseshoe. It's the one time you can't. Okay, if they're not telling you that, I'm telling you that. Okay, how should you evaluate this argument? Right? G, then H, J, then